What if death wasn't the end? No afterlife, no reincarnation, just endless existence. Not because of some supernatural force, but because of physics itself. Sounds impossible, right? But what if I told you that every time you should have died, every time you came dangerously close to the end, some version of you actually did? And yet, here you are, always surviving, always continuing. Think about it. That near-miss accident, that 1 in a million chance you made it through. Ever wonder why you keep making it? What if you never actually die? Not from an accident, not from old age, not from anything? It sounds insane, but according to quantum physics, this might not just be a wild theory. It might be reality. Because in the strange world of quantum mechanics, particles don't work the way we think. They exist in multiple states at once, until someone observes them. That means reality, at its most fundamental level, is not fixed. It's fluid. And some physicists believe this doesn't just apply to tiny particles. It applies to you. Think of it this way. Imagine flipping a coin. Heads or tails, right? But what if, instead of landing on one side, the universe split into two? One where it landed on heads, another where it landed on tails. Now, replace the coin flip with something bigger, like life and death. Every time you should have died, reality splits. In one version, you're gone. But in another, you're still here. This isn't science fiction. It's a real interpretation of quantum mechanics called quantum immortality. And if it's true, it means you might live forever, without even realizing it. But before you get too excited, think about this. What if living forever isn't a good thing? What if it's the worst fate imaginable? Because while you might never die, you might never truly live either. It's a theory that could change everything we know about existence. So, is quantum immortality real? Or just a terrifying thought experiment? Let's dive into the strangest idea in science. Quantum physics is weird. Not just weird, downright bizarre. It's a world where particles can be in two places at once, where time doesn't always move in a straight line, and where reality itself seems to change depending on whether or not we look at it. It breaks every rule of common sense. It shouldn't make sense. And yet, this is the foundation of how our universe actually works. But what if I told you that these strange quantum rules don't just apply to tiny particles? Some physicists believe they apply to you too, to your consciousness, to your very existence. Think about this for a moment. You wake up every morning and assume you are in the same reality as yesterday. But what if you weren't? What if, in some other version of reality, you didn't wake up at all? And what if you never actually die? Not in the way we think. What if, no matter what happens, some version of you will always experience being alive? This idea might sound like pure science fiction, but it's not. It's a legitimate interpretation of quantum mechanics, called quantum immortality. And if it's true, it changes everything we think we know about life and death. Now, before we go any further, let's take a step back. Quantum mechanics is already mysterious enough without bringing immortality into the equation. But to understand why some scientists believe this is possible, we need to first understand why quantum physics itself is so strange. You see, in our everyday world, things seem pretty straightforward. If you flip a coin, it lands on heads or tails. If you knock over a glass of water, it spills. Things happen in a clear, predictable way. But at the quantum level, this kind of predictability disappears. In the quantum world, a particle, say an electron, doesn't just exist in one place at a time. It exists in multiple places at once. It's in a state of superposition, meaning it has all possible outcomes existing simultaneously until someone observes it. The moment it's observed, It chooses one reality. But before that, it exists in all of them. This is completely different from the world we experience. It's as if reality itself remains undecided, floating in a cloud of possibilities until someone forces it to settle on one version. And here's where things start to get really strange. If the fundamental building blocks of reality can exist in multiple states at once, what does that mean for larger systems? What does it mean for us? Some scientists argue that this weirdness doesn't just apply to tiny particles. It applies to everything, including you. They believe that, just like an electron being in two places at once, you could also exist in multiple states at once. And that includes a state where you survive something you weren't supposed to. Imagine you get into a life-threatening accident. In most versions of reality, you don't make it. But if reality behaves like the quantum world, then there must be at least one version of reality where you do. And if you can only experience being alive, then your consciousness must continue in that surviving version every single time. This is the core idea of quantum immortality, that no matter how bad things get, no matter how certain death seems, there will always be a version of reality where you keep going. And since you can never experience being dead, you will always experience being alive. Sounds terrifying? You're not alone. Even physicists don't fully understand what this could mean. But the idea comes from an actual interpretation of quantum mechanics, called the many worlds interpretation. This theory suggests that every possible outcome of a quantum event happens, but in separate, parallel universes. So instead of a single reality, where things play out one way, there are countless realities where every possibility unfolds. According to this view, every decision you make, every accident, every event, big or small, creates new branches of reality. There's a universe where you took a different path to work today. There's a universe where you never started watching this video. And if this theory is correct, there are also universes where you lived, and universes where you didn't. But if reality keeps splitting, what happens when you die? Do you stop experiencing reality? Or does your consciousness always continue in the versions of reality where you survive? That's the question at the heart of quantum immortality. Now, before we try to answer it, let's take a step back and ask a different question. Why would anyone believe this in the first place? What evidence or logic suggests that something as wild as quantum immortality could actually be real? To find out, we need to start with one of the strangest mysteries in quantum physics. A mystery that has puzzled scientists for decades. The mystery of quantum superposition. To understand the concept of quantum immortality, we first have to explore something much deeper. Something that challenges our very perception of reality. It's a phenomenon that has puzzled scientists for decades. Something so bizarre that even the greatest minds in physics struggle to explain it. It's called superposition, and it may hold the key to understanding how the universe truly works. Imagine flipping a coin. In our everyday world, it lands on either heads or tails. There's no in between. Once the coin settles, the result is final, definite, and clear. This is how we expect the world to function. Things are either one way or another, not both. But at the smallest scales of reality, the world doesn't work like this at all. In the realm of quantum mechanics, particles behave in ways that defy logic. They don't choose a single state immediately. Instead, they exist in all possible states at the same time until something forces them to take on a specific form. This means that, before we measure it, a quantum particle isn't just in one place or another, it's in both places at once. It isn't just moving in one direction, It's moving in every possible direction at the same time. This is what scientists call superposition, and it is one of the most mind-bending principles in physics. This idea was first introduced in the early 20th century, when scientists began to study the behavior of subatomic particles. What they found was nothing short of shocking. Experiments showed that tiny particles, like electrons or photons, acted as if they were in multiple states simultaneously. They could be detected in different places at the same time. They could travel through two slits at once, interfering with themselves like waves, rather than behaving like solid objects. It was as if reality itself remained undecided until something forced it to make a choice. But what does that really mean? How can something be in two states at once? To make sense of this, physicists came up with a thought experiment that would help illustrate just how strange quantum mechanics really is. Imagine a cat inside a sealed box. Along with the cat, there's a device that is triggered by a completely random quantum event, such as whether a radioactive atom decays. If the atom decays, the device releases poison and the cat dies. If it doesn't decay, the poison is never released and the cat remains alive. Now, in the normal world, we'd expect one of two things to happen. Either the atom decays, the poison is released, and the cat dies, or the atom doesn't decay, and the cat lives. But in the quantum world, things are far stranger. Since the atom exists in a state of superposition, both decayed and not decayed, the fate of the cat is also in superposition. This means that until someone actually opens the box to check, the cat is neither alive nor dead. It exists in both states at the same time. Only when someone observes the cat does reality decide on one outcome. This bizarre idea, known as Schrödinger's cat, became one of the most famous paradoxes in physics. It wasn't just a theoretical puzzle. It pointed to a fundamental mystery in the way reality operates. Does the universe truly wait for us to look at something before deciding what's real? And if so, what does that say about the nature of existence itself? For decades, the leading explanation for this mystery was something called the Copenhagen interpretation. This interpretation suggests that quantum particles exist in all possible states until they are observed. The act of measurement causes the wave function, the mathematical description of all these possibilities, to collapse into a single reality. In other words, reality doesn't fully exist in one form until we interact with it. But not everyone was convinced by this explanation. The idea that observation itself determines reality seemed unsettling, even absurd. It implied that the universe somehow cares about whether or not we're looking. That didn't sit well with many scientists, and they began to look for alternative explanations. Then, in 1957, a young physicist named Hugh Everett proposed something radical. What if the wave function never collapses? What if, instead of one possibility winning over the others, all possibilities happen, but in different, separate realities? According to Everett's idea, every time a quantum event occurs, the universe splits into multiple branches, each one corresponding to a different outcome. In one version of reality, the cat is alive. In another, the cat is dead. Both realities exist, but they never interact with each other. Each branch of the universe moves forward independently, unaware of the others. This idea became known as the many worlds interpretation, and it completely rewrote the rules of quantum mechanics. Instead of reality choosing one outcome, every possible outcome happens somewhere. Every decision, every quantum event, every random occurrence creates new universes that continue to exist, each with its own version of history. At first, the many worlds interpretation sounded like pure science fiction. The idea that countless parallel realities were constantly being created seemed too wild to be true. But as scientists studied quantum mechanics further, they realized that this idea actually solved many of the paradoxes that had plagued physics for decades. If Everett was right, then superposition wasn't a weird, temporary state that collapsed when we observed it. Instead, it was a real, physical effect. Particles really did exist in multiple states at once, but each state existed in its own separate universe. Over time, this interpretation gained more and more support. Experiments in quantum mechanics seem to align with the idea that wave functions didn't collapse in the way the Copenhagen interpretation suggested. Instead, it appeared that reality was continuously splitting, branching into infinite possibilities every moment. But if this is true, then it leads to a disturbing question. What does it mean for us? If reality keeps branching, then every possible version of our lives must exist somewhere. There must be a universe where you made different choices, where your life turned out differently, where events unfolded in ways you never imagined. But more importantly, if this interpretation applies to all quantum events, then what happens when you die? This is where things get truly unsettling. If every possible outcome of a quantum event occurs in some version of reality, then doesn't that mean there must always be a version of you that survives? No matter how unlikely, as long as there's even the tiniest chance of survival, there must be a reality where you keep going. And if you can only experience the realities where you are alive, then from your perspective, you might never actually die. This is the core of the idea known as quantum immortality. It's a theory based on the many worlds interpretation, and if it's true, then no matter what happens, some version of you will always experience being alive. Of course, this idea is controversial. Many physicists reject it outright, arguing that consciousness doesn't necessarily follow the rules of quantum mechanics. But if the many worlds interpretation is correct, then it raises questions that we can't easily ignore. So, is quantum immortality real? Could it actually happen? To answer that, we need to go deeper. We need to explore what happens when reality splits, and what it truly means to exist across multiple universes. And to do that, we need to consider one of the most disturbing thought experiments ever conceived. One that tests the very limits of what it means to be alive. Many worlds and the idea of splitting realities. In 1957, a young physicist named Hugh Everett III proposed something radical, something that, if true, would change our entire understanding of reality. His idea was simple, yet shocking. What if the universe doesn't just pick one outcome when a quantum event occurs? What if, instead of collapsing into a single reality, the universe splits into multiple, parallel versions, each one playing out a different possibility? This idea is now known as the many worlds interpretation of quantum mechanics, and it remains one of the most debated and fascinating theories in modern physics. But to understand why Everett's theory is so groundbreaking, we first need to understand the problem it was trying to solve. For decades, physicists struggled to make sense of one of quantum mechanics' strangest features: superposition. Superposition tells us that before we observe a particle, it exists in multiple states at once. A single electron, for example, doesn't have a definite position until we measure it. Until that moment, it exists in all possible positions simultaneously. But the moment we observe it, it chooses one reality. This creates a huge question. What happens to all the other possibilities? Do they just vanish? For years, the leading explanation was something called the Copenhagen interpretation, which argued that quantum states collapse the moment they're observed. In other words, reality doesn't exist in a definite state until someone looks at it. But Everett thought differently. He proposed that the wave function, the mathematical object that describes all possible states of a system, never actually collapses. Instead, all possible outcomes continue to exist, just in separate, non-communicating branches of reality. Imagine flipping a coin. In the traditional way of thinking, the coin lands on either heads or tails, and that's the end of the story. But in the many worlds interpretation, both possibilities occur. The universe simply splits into two versions. In one universe, the coin lands on heads. In another, it lands on tails. This means that reality isn't a single, continuous thread. It's an ever-branching tree, with countless alternate versions of history unfolding in parallel. And this branching process isn't limited to coin flips. It applies to everything. Did you pass an important test? There's a universe where you failed. Did you decide to take a different route home? There's a universe where you stuck to your original path. Did you survive a life-threatening event? There's a universe where you didn't. Every single quantum event, big or small, results in a split, creating a new branch of reality where a different outcome plays out. And if this is true, then the implications are staggering. One of the most mind-bending consequences of many worlds is that every possible version of you exists somewhere. There's a version of you that made every right decision. A version of you that took risks and won. A version of you that became a billionaire, an astronaut, or a world-famous artist. But there's also a version of you that made every wrong decision. A version of you that took a small misstep that led to disaster. A version of you that lost everything. And if reality is constantly splitting like this, it raises an even more disturbing question. What happens when you die? Normally, we think of death as final. When someone dies, they're gone. Their consciousness ends. But if the many worlds interpretation is correct, then things might not be that simple. Consider this. Let's say you're in a situation where you should have died. Maybe you were in a terrible car accident. Maybe you had a terminal illness. Maybe you were in a life-threatening crisis. In most branches of reality, you don't make it. You die just like anyone else. But in at least some universes, no matter how small the chance, you survive. Maybe you barely escape. Maybe a medical breakthrough saves you. Maybe something completely unexpected prevents your death. And here's where things take a turn. If you are only capable of experiencing consciousness in the realities where you are still alive, then you will always find yourself in those surviving universes. No matter how many close calls you have, you will always continue experiencing life, simply because you can't experience being dead. This is the foundation of quantum immortality. The idea suggests that, from your perspective, you will always survive, because in every life-threatening scenario, there will always be some version of reality where you make it. Even if the odds are astronomically low, as long as a survival path exists, that's the path your consciousness will follow. But this isn't necessarily a good thing. While quantum immortality suggests that you may never experience death, it doesn't promise that you'll enjoy what comes next. Imagine a reality where you survive a deadly illness, but only after suffering unimaginable pain. Imagine living through an accident, but being permanently disabled as a result. Imagine growing older and older, but never being able to escape a deteriorating body. Some physicists have argued that this could lead to an unthinkable fate, an eternity of suffering. Because while you might never experience a reality where you fully cease to exist, you could find yourself trapped in versions of reality where survival comes at a terrible cost. Of course, this is all theoretical. Most scientists don't actually believe quantum immortality is real, and for good reason. There are several major problems with the idea. Problems that suggest reality doesn't actually work this way. For one, just because an unlikely outcome exists doesn't mean your consciousness must always follow that outcome. In fact, the vast majority of possible futures still lead to death, and there's no evidence that our minds choose the paths where we survive. Another issue is the nature of identity. If another version of you exists in a different universe, is that really you, or just a copy? If your consciousness continues in one branch, while another version of you dies in another, are they truly the same person? Or just alternate versions, each with their own independent experience? And then there's the biggest problem of all. There's no way to test any of this. Science is built on experiments and evidence, but quantum immortality is impossible to verify. The only way to know for sure is to die. And by then, it's a little too late to figure it out. Still, even if quantum immortality turns out to be nothing more than a thought experiment, it forces us to ask big questions about the nature of reality, consciousness, and what it truly means to exist. Because if the many worlds interpretation is correct, if every possibility really does play out somewhere, then somewhere, right now, there's a version of you who made every right decision, a version of you who lived the best possible life, a version of you who might one day unlock the secrets of the universe. But can we ever know for sure? And if there really are infinite versions of reality, what does that mean for the future? To answer that, we need to take a closer look at one of the strangest thought experiments ever proposed. A scenario so unsettling that it makes quantum immortality feel even more disturbing. The quantum Russian roulette thought experiment. Imagine a scenario so bizarre, so unsettling, that it forces us to question the very nature of existence itself. Imagine you're holding a loaded gun, playing a game of Russian roulette. You pull the trigger. There are two possible outcomes. Either the bullet fires and you die instantly, or the gun misfires and you survive. In our everyday understanding of reality, only one of these outcomes can happen. You either live or you don't. Simple, right? But what if that's not how reality works? According to the many worlds interpretation of quantum mechanics, both versions of the event actually occur. In one universe, the bullet fires and you die. In another, the gun misfires and you walk away unharmed. Normally, this idea of parallel outcomes might not seem like much more than an abstract thought experiment. But here's where things take a disturbing turn. You, as a conscious being, can never experience your own death. You won't be around to perceive the reality where you die. The only reality you will ever be aware of is the one in which you survive. So, every time you face death, reality splits. One version of you ceases to exist. Another version continues on, completely unaware that in countless other realities, things played out differently. Now, let's take this idea further. If the universe constantly branches, if every possible outcome of a life or death situation exists in some version of reality, then there must always be a version of you that continues surviving, no matter what. It doesn't matter how unlikely survival is. As long as there is even the tiniest fraction of a chance that you live, there is always a reality where you do. And here's the terrifying conclusion. From your own subjective experience, you will never encounter a reality in which you cease to exist. Your conscious self will always wake up in the branch where you survived. This is quantum immortality. It doesn't mean that other people will see you live forever. In most universes, you die just like anyone else. But in your personal experience, there is no such thing as an end, no final blackout, no nothing, only continuity. At first, this might sound incredible, an endless life, an existence that defies death itself. But then, reality sets in. Because if this theory is true, then immortality is not a gift. It's a curse. Think about it. if you can never truly die, you will live through every possible way of almost dying. You might survive accidents, but with devastating injuries. You might endure illnesses that should have ended your life, but instead leave you barely functioning. You might age beyond anything imaginable, your body deteriorating, but your consciousness still trapped inside. This horrifying scenario is sometimes referred to as the quantum hell hypothesis. You might keep surviving, but that doesn't mean you'll remain whole, happy, or even sane. If quantum immortality is real, then it doesn't grant you an eternal, youthful existence. It forces you to endure every possible way in which you could continue, no matter how painful, no matter how unbearable. This concept was even explored in literature centuries ago, long before quantum mechanics existed. In Jonathan Swift's Gulliver's Travels, there's a group of people called the Struldbrugs, immortals who never die, but who also never stop aging. Over time, they become frail, senile, and miserable, trapped in a decaying existence with no way out. They live forever, but without purpose or relief. And that's exactly the problem with quantum immortality. It doesn't mean you become invincible. It just means that, no matter what, you always experience being alive in some reality, even if that reality is one where you wish you weren't. Now, this all sounds terrifying, but before we get carried away, we have to ask an important question. Could any of this actually be real? Or is it just a strange, unprovable idea? Many physicists dismiss quantum immortality for a variety of reasons. The biggest problem is probability. Just because a version of reality exists where you survive, doesn't mean your consciousness must continue in that one. It's entirely possible that most versions of you simply cease to be, and there's no special rule forcing your awareness to follow the few surviving ones. Then, there's the problem of identity. If another version of you exists in a separate universe, is that really you? Or just an identical copy that only thinks it's you? If quantum immortality relies on consciousness, jumping between realities, then we have to define what you even means in the first place. And so far, science doesn't have a clear answer. And even if we accept the many worlds interpretation, it doesn't automatically mean quantum immortality must be true. The many worlds theory suggests that all possible outcomes occur, but that doesn't necessarily mean that an individual's consciousness will always align with the surviving versions of themselves. There's no experimental proof, no way to test it, no way to know for sure. So, is quantum immortality just a wild thought experiment? Or is there something deeper to it? Could our consciousness truly be tied to the strange mechanics of the quantum world? And if it is, what does that mean for our understanding of life and death? These are the questions we now need to explore. But before we try to answer them, let's go back to the beginning, to the mystery that started it all. The idea that reality itself doesn't behave the way we think it should. To truly understand whether quantum immortality could be real, we first need to understand the fundamental problem at the heart of quantum mechanics. A problem that has puzzled scientists for over a century. The horror of immortality, a fate worse than death. Imagine for a moment that you are truly immortal. Not in the way that myths and legends describe, not as an eternal, youthful being, untouched by time, but as something far stranger. Every time you should have died, reality splits. Somewhere, in some version of the universe, you keep going. Every bullet that should have killed you, every disease that should have ended your life, every catastrophe that should have been your last. Somehow, in your experience, you always make it through. But here's the terrifying part. Surviving doesn't mean staying the same. It doesn't mean you emerge from every close call unscathed. Surviving doesn't promise you a healthy body, a sound mind, or a painless existence. If this theory is correct, then you might live forever, but in the worst way imaginable. At first, this might not seem so bad. After all, who wouldn't want to escape death? The idea of continuing on, of having endless chances, sounds appealing, at least on the surface. But let's look deeper. Let's consider what happens when time, suffering, and decay keep going, without an end. Think of the sheer number of ways a person can experience pain. The body is fragile. It ages, it breaks, it wears down. Even if you survive every fatal event, that doesn't mean you heal from it. It doesn't mean you regenerate like a superhero. If you get into an accident and lose a limb, you don't grow it back. If you suffer brain damage, you don't suddenly regain full function. Each survival comes with a price. Over time, you could find yourself in a state where every survival leaves you worse off than before. Your body could weaken. Your mind could deteriorate. You could lose your memories, your ability to think clearly, even your sense of self. And yet, you would still be alive. Because, according to the logic of quantum immortality, your consciousness will always persist in some timeline. This isn't a new fear. The idea of immortality as a curse has existed in human storytelling for centuries. One of the earliest examples comes from Jonathan Swift's Gulliver's Travels, in which he describes a race of beings called the Struldbrugs. Unlike other mythical immortals, the Struldbrugs don't stay young forever. They continue aging, growing more frail, more decrepit, more miserable. Their minds erode, their bodies fail, and they are trapped in an existence of endless suffering. They can never die, but they can never truly live either. Physicist David Lewis used this as a metaphor for the potential consequences of quantum immortality. If you survive every fatal event, eventually you might end up in a state where survival itself is worse than death. And here's where things get even darker. There are conditions today that already push people into extreme, prolonged suffering. There are neurological diseases that leave people locked inside their bodies, fully aware but unable to move or communicate. There are degenerative disorders that erase memories, leaving people as shadows of their former selves. If quantum immortality is real, then eventually you could find yourself experiencing something like this forever. Because no matter how badly your body breaks down, there will always be some timeline where you keep going. Your brain might barely function, your thoughts might slip into incoherence, but there will always be some version of you that remains aware, no matter how small that awareness becomes. And since you cannot experience non-existence, you would never know the relief of death. You would only experience an endless, stretched out moment of survival. Now, some might argue that consciousness wouldn't work this way. That at some point, the brain would simply fail to be you. But even that assumption is uncertain. The human mind is not fully understood. There is no clear-cut definition of when identity ceases. And if the many worlds interpretation of quantum mechanics holds true, then as long as there is even a sliver of awareness left, you will continue experiencing existence. But there's an even more unsettling possibility. What if your consciousness doesn't just exist in a failing body? What if, over countless lifetimes of survival, you end up in realities that are beyond your comprehension? What if the conditions of the universe itself change in ways that leave you trapped in something worse than a deteriorating body? Trapped in an entirely different kind of nightmare. If quantum immortality means your consciousness always persists, then what happens when the Earth becomes uninhabitable? What happens when the sun expands, swallowing the planet? What happens when the universe itself reaches the end of its lifespan? Could there be some version of reality where you remain aware even after everything else is gone? Of course, this is all speculation. No one knows for sure if quantum immortality is real, and even if it is, no one knows exactly how consciousness functions in the grand scheme of quantum mechanics. But the mere possibility raises disturbing questions. Would you really want to live forever if it meant endless decay? If it meant surviving every possible horror, no matter how agonizing? If it meant clinging to existence long after everything that made life meaningful had vanished? And this brings us to the next question, the most important question. Is quantum immortality even possible? Is quantum immortality real, or just a wild thought experiment? To find out, we need to look at the science. While the idea is strange and even unsettling, there are good reasons to doubt it. Most physicists don't believe it, saying it misinterprets quantum mechanics and has no real proof. The many worlds theory suggests endless realities, but that doesn't mean you keep living in all of them. The truth is likely far more complicated, and this idea raises more questions than answers. Let's take a closer look. The probability problem. One of the biggest issues with the idea of quantum immortality is probability itself. Just because there is some possibility of survival in a few universes doesn't necessarily mean your consciousness must always continue in those. The vast majority of possible realities still lead to death, and just because you don't experience those outcomes doesn't mean they don't exist. To understand why this is a problem, we need to take a step back and look at probability itself, how likely events are to happen, and how they shape what we actually experience. Let's start with a simple example. Rolling a six-sided die. If you roll the die, there are 6 possible outcomes, each with an equal chance of happening. Now, imagine that for every roll, the universe splits into 6 different versions. One where the die lands on a 1, one where it lands on a 2, and so on. If you could only experience one of these outcomes, it might seem like the other 5 never happened. But they did. You just aren't aware of them. Now let's extend this to something more significant, like a life or death scenario. Suppose you are in a dangerous situation, like a severe car accident. In some realities, the crash is fatal. In others, you barely survive with injuries. In a very small number, you walk away completely unharmed. If the many worlds interpretation is true, then all these outcomes exist in parallel universes. But the crucial question is, why should you only experience the ones where you survive? The argument for quantum immortality suggests that because you can never experience being dead, your consciousness will always continue in the realities where you make it through. But this assumption has a flaw. Just because a possibility exists doesn't mean it's the most likely outcome. Let's go back to the die example. Imagine rolling a die, but this time 5 sides mean instant death, while only one side means survival. If you roll it once, you might get lucky and land on the side that lets you live. But if you have to roll it over and over again, eventually you're going to land on one of the fatal sides. You can't keep rolling forever and only expect to see the one rare outcome. This is the core problem. If quantum immortality were true in the way some people think, we would have to assume that consciousness only continues in the rarest branches of reality where survival is possible, no matter how improbable. But probability doesn't work like that. Most branches still lead to death. You just wouldn't be aware of them. To put it in more relatable terms, let's consider the lottery. Every time someone buys a lottery ticket, there is a small chance they will win. But the vast majority of people don't win. The universe doesn't just create a version of reality where everyone gets lucky and wins. Instead, most people experience the more likely outcome. They lose. Now, let's apply this to life-threatening situations. If you were to take increasingly dangerous risks, like playing Russian roulette, the probability of survival keeps dropping. The argument for quantum immortality suggests that, because you can never be aware of your own death, you would always find yourself in the universes where the gun misfires. But in reality, probability says that most versions of you are no longer conscious at all. To make this even clearer, imagine a person attempting a nearly impossible escape from a collapsing building. There may be one universe where every single move they make is exactly right, where they narrowly avoid every falling piece of debris and find the one safe exit. But the vast majority of versions of this person are not that lucky. Most of them do not make it out. Just because one small probability exists does not mean it must always happen. A real-world example of probability shaping reality is aviation safety. Let's say you are on a plane and there is a mechanical failure. There might be a small chance that the plane will land safely and another chance that it won't. If you followed the logic of quantum immortality, you would only experience the universes where the plane lands safely. But in reality, the overwhelming probability is that planes that experience catastrophic failures don't make it. This is why we see real-world statistics that match expected probabilities, because we are not selectively experiencing only the rarest outcomes. Another interesting way to look at probability is through extreme medical cases. There are occasional reports of people surviving impossible situations, falling from great heights, being shot multiple times, or living with fatal illnesses far beyond what doctors expected. These cases are incredibly rare, but they do happen. If quantum immortality were real, we might expect to hear about people surviving every fatal situation, not just a handful of them. Instead, what we actually see is that, while survival in unlikely circumstances is possible, it is the exception, not the rule. A final example comes from genetics and natural selection. Evolution is based on probability. If a species faces extreme environmental pressures, only the individuals best suited to survive will pass on their genes. Most of the others do not. Over time, the more likely outcomes dominate, while the less likely ones fade away. The same principle applies to human survival. If probability dictates that most outcomes lead to death, then those are the ones that dominate the overall picture. So, does this mean quantum immortality is completely impossible? Not necessarily. But what it does mean is that even if the many worlds interpretation is correct, your consciousness is still subject to the rules of probability. The vast majority of versions of you do not experience survival in every case. Even if some realities exist where you continue, the argument that you must experience only those is flawed. You are not guaranteed to always land on the winning side of probability. Most versions of you simply cease to exist, and the fact that you don't experience those versions doesn't mean they aren't there. In the end, the probability problem is one of the strongest arguments against quantum immortality. It suggests that even if the universe does split into countless branches, your consciousness doesn't have special rules that allow it to bypass the most likely outcomes. Just like with rolling dice, playing the lottery, or surviving real-world dangers, probability dictates that most outcomes lead to an end. And if that's true, then no matter how strange quantum physics is, the reality remains the same. Death is not something you escape just because another possibility exists. The measure problem, another one of the biggest misconceptions about the many worlds interpretation of quantum mechanics, is the idea that all possible realities are created equally. When people first hear about it, they often imagine a constantly branching multiverse where every single possibility, no matter how small, must exist somewhere. A world where you could flip a coin, and not only would there be one universe where it landed on heads and another where it landed on tails, but also a universe where the coin vanished into thin air or transformed into a butterfly. But that's not quite how it works. Yes, the many worlds interpretation suggests that reality splits with every quantum event, but not all outcomes are equally likely. Some realities are simply far less probable than others, so much so that they might as well not exist for any practical purpose. This is what physicists call the measure problem. To understand this, we need to go back to the foundations of quantum mechanics. In the quantum world, particles don't behave like tiny billiard balls rolling around in a predictable way. Instead, they exist as probability waves, mathematical functions that describe all the possible places or states they could be in. When we make a measurement, the wave function collapses, and we get one specific result out of many possibilities. In the many worlds interpretation, instead of the wave function collapsing into one reality, it simply evolves into separate branches, each corresponding to a different possible outcome. However, these branches don't all have the same weight or significance. Some are vastly more likely than others. To see how this works, imagine rolling a standard six-sided die. In the classical world, when you roll the die, you get one outcome, let's say a 3. The other 5 outcomes never happened. But in the many worlds interpretation, the universe splits into 6 different branches. One where you rolled a 1, one where you rolled a 2, one where you rolled a 3, and so on. Now, let's modify this experiment. Suppose we use a weighted die, one that is rigged to land on a 690% of the time, and on any other number only 2% of the time. In the many worlds view, there would still be universes where you rolled a 1, 2, 3, 4, or 5, but they would be far less common than the ones where you rolled a 6. This is a simple example of how different outcomes have different probabilities, even in a branching multiverse. Just because a possibility exists doesn't mean it happens with the same frequency, or even that it happens at all in a meaningful way. Now, let's apply this to something much more extreme: survival in life-threatening situations. If the many worlds interpretation is true, then theoretically, every time you face a situation where you could die, there are branches of reality where you survive. But here's the catch. The probability of survival in some situations might be astronomically low. Imagine you're in a plane that's about to crash. The engines fail, the plane is plummeting, and the chances of survival are close to 0. In some universe, you survive. Maybe because of an unlikely chain of events where the plane lands just right, or you're miraculously thrown into a safe spot. But those universes are incredibly rare compared to the overwhelming majority where you don't survive. This is the key point of the measure problem. Even if an outcome is technically possible, that doesn't mean it has a high enough probability to matter. If one reality happens 99.9999999% of the time, and another happens 0.000000001% of the time, the second one might exist, but it's so insignificant that it's essentially meaningless. Let's take it one step further and look at something even more extreme: quantum tunneling. Quantum tunneling is a real, observed phenomenon where particles can tunnel through barriers that should be impossible to cross. In the microscopic world, electrons do this all the time, and it's one of the principles that allows modern electronics, like transistors, to work. But what if quantum tunneling happened at the macroscopic level? What if a person suddenly teleported through a wall because their atoms, by sheer quantum chance, all tunneled at the same time? In theory, it's possible. There is an unimaginably tiny probability that all the particles in your body could spontaneously tunnel through a wall, allowing you to walk through solid matter like a ghost. But but the probability of this happening is so low that you would need to wait longer than the age of the universe to even have a realistic chance of seeing it happen once. Now, apply this idea to quantum immortality. Even if there are universes where you survive every single time you should have died, they could be so vanishingly rare that they might as well not exist at all from any practical standpoint. The overwhelming weight of probabilities still points to death. This is why most physicists don't take quantum immortality seriously. Even in a many worlds framework, survival isn't guaranteed. Sure, there might be a version of reality where you lived through something impossible, but the vast majority of your other selves didn't. Your personal experience, your consciousness, doesn't necessarily have to follow only the surviving versions. Another way to think about it is lottery tickets. If you buy 1 million lottery tickets, there is some small chance that one of them wins the jackpot. But does that mean you should assume you will win? Number. The overwhelming probability is that you won't. Just because a winning outcome exists doesn't mean it's the one you should expect to experience. The same principle applies to life and death in the many worlds interpretation. Yes, somewhere, some version of you might beat the odds every single time. But that version is so unlikely that it's not the reality you should expect to experience. And there's another problem. Even if your consciousness somehow did always follow the surviving versions of yourself, you wouldn't be aware of the countless other versions of you that died. In every other branch of the universe, your friends and family would experience a reality where you didn't make it. So from their perspective, quantum immortality is meaningless. It doesn't change anything about how the world works. In the end, the measure problem reminds us that probability still matters, even in a multiverse. Just because something is possible doesn't mean it's significant. Not all realities are created equal. Some are far more likely than others, and the ones that are least likely, like the versions of you that survive every impossible event, are so rare that they might as well not exist at all. This is why quantum immortality remains a fascinating but highly questionable idea. It's not just that it's impossible to test, it's that it fundamentally misunderstands how probability and the many worlds interpretation actually work. So, while it's fun to imagine a universe where we live forever, the reality is probably far less dramatic. In most versions of reality, life plays out exactly as we expect, because probability still rules the universe, even if it's an infinite one. The identity problem. If another version of you exists in a different universe, is that really you, or just a copy? This question isn't just a philosophical exercise. It's at the heart of one of the biggest mysteries in quantum mechanics and the many worlds interpretation. If reality is constantly splitting, creating new versions of yourself with every quantum event, then what exactly makes you, you? To understand this, we need to break down what identity really means. At first glance, it seems obvious. You are you because of your thoughts, memories, and experiences. Everything that makes you who you are, the way you think, the way you feel, the sum of all your past decisions, is unique to you. But if an identical copy of you existed somewhere else, would that person also be you? Let's start with a simple thought experiment. Imagine that right now, at this exact moment, an identical copy of you appears somewhere else in the universe. This copy has your memories, your personality, and every single thought you're having right now. From their perspective, they are you. If they wake up tomorrow, they'll remember everything you remember. If they feel pain, they'll react just like you would. But here's the catch. You still exist. There are now two versions of you, both completely identical, at least for now. The moment this copy starts making different choices, they become slightly different from you. Maybe they get up from their chair a second later than you do. Maybe they decide to drink water instead of coffee. These tiny changes add up over time, and before long, they are no longer an exact copy. They are now a separate person, one who just happens to share your past. This is where things get complicated when we talk about the many worlds interpretation. If reality constantly branches off with every quantum event, then there isn't just one copy of you. There are countless versions of you, all existing in different universes. Some of these versions are nearly identical to you, while others have made drastically different choices and lived completely different lives. Now, the real question: if you were to suddenly switch places with one of these alternate versions of yourself, would you even notice? Let's say that in one universe, you decided to take a different route home. In another, you didn't. These two versions of you are nearly identical, except for that one small decision. If you suddenly swapped places with your other self, would you feel any different? Probably not. Your brain wouldn't register the switch because your memories and sense of self would still feel continuous. But what if we take this idea further? Imagine a futuristic scenario where scientists invent a teleportation machine. To teleport you from one place to another, the machine scans every single atom in your body, destroys the original, and reconstructs an exact copy somewhere else. From the outside, it looks like you've teleported. But did you really? Or did the machine just kill the original you and create a perfect duplicate that only thinks it's the same person? This is essentially the same problem many worlds presents. If the universe is constantly making copies of you in different branches of reality, then are those copies really you? Or are they just versions of you that share your past but are ultimately separate individuals? The issue becomes even more unsettling when we apply it to quantum immortality. If every time you should have died, your consciousness simply continues in the reality where you survive, then which version of you is the real you? Are you just hopping between realities without realizing it? Or is the you experiencing this video right now simply one of many versions, each believing themselves to be the only real one? To make this more relatable, consider identical twins. Twins start as the same genetic entity, but split early in development, becoming two separate people. They share nearly the same DNA, but their experiences diverge, shaping them into unique individuals. Now imagine that instead of just one split at birth, every single moment of your life created another twin. Every decision, every chance event, every possibility plays out in some reality, creating more and more versions of you. Are all of them you? Or just slightly different individuals who all think they're the original? One way to approach this problem is through the concept of continuity of consciousness. Your identity feels real to you because your memories and experiences form an unbroken chain. You remember waking up this morning. You remember your childhood. The sense of self is based on the continuity of these memories. But if another version of you exists somewhere else, even with the same memories, that continuity doesn't exist between you and them. Their thoughts are not connected to yours. You don't experience what they experience, even if they think they are you. This suggests that identity isn't just about having the same information. It's about having a continuous, unbroken experience. To put it another way, imagine you went to sleep tonight and woke up in a completely different body with the same memories and personality. Would you still be you? Most people would say yes, because your consciousness is still continuous. But if instead, an identical copy of you was created and the original you was erased, that copy might believe it's the same person. But is it? The same issue applies to the many worlds interpretation. If countless versions of you exist, then no single one of them can truly claim to be the original. Every version believes they are the real one, but in reality, they are all just separate individuals, branching off in their own directions. So, does quantum immortality actually preserve you? Or does it just ensure that some version of you is always alive, even if it's not the exact same consciousness? This is the fundamental problem. If every time you should have died, a surviving version of you continues in another reality, then the version of you that did die still ceases to exist. From their perspective, death is still real. They don't experience quantum immortality because their consciousness doesn't continue. And here's the disturbing part. If quantum immortality is real, then none of us will ever experience dying. We will always find ourselves in the reality where we survived. But this means that countless versions of us will still perish in other branches of reality, and we will never know it. At the end of the day, the identity problem makes quantum immortality even more unsettling. Because even if you do live forever in some reality, the question remains, is it really you that keeps going? Or just a version that thinks it is? And if all of this is true, what does that say about the nature of existence itself? At the end of the day, quantum immortality remains an unprovable mystery. You can't test it. You can't measure it. No experiment can confirm whether your consciousness truly jumps between realities. The only way to know for sure is to die. But even then, you wouldn't be around to verify it. Maybe, in some version of reality, you always survive. Maybe right now, you're already experiencing it without even realizing it. But if that's the case, what does it actually mean for you? What if it is real? But let's assume, just for a moment, that quantum immortality is real. What does that actually mean? It means that no matter how many times you should have died, no matter how unlikely your survival, your consciousness always finds a way to keep going. It means that, for you, death is an illusion. The people around you may see you die. They may mourn you, bury you, and continue their lives without you. But for you, subjectively, there will always be a reality where you survive. Think about that for a second. Every near miss, every close call, every moment where things could have gone horribly wrong, some version of you kept going. Maybe you remember a time in your life when you should have been seriously hurt, or worse, but somehow you weren't. Maybe it was luck. Or maybe in another universe, you weren't so lucky and you just never experienced that version of reality. Now take that idea to its extreme. If there is always a version of reality where you survive, then that means, from your perspective, you will never truly experience death. You might age, you might suffer, you might reach points where survival seems impossible. But something, some strange unexplainable force, will always keep you on the path where you continue to exist. This should be comforting, right? The idea that you will never die? But is it? Because if this theory is true, then it's not just about survival. It's about eternity. It's about being trapped in an endless cycle of existence, never able to truly rest. And the longer you live, the more you might lose, the more pain you might endure. Imagine surviving every disaster, every illness, every accident, only to find yourself in a world where everything familiar has disappeared, where everyone you've ever known has died, where you are left to continue endlessly, while reality itself warps and shifts around you. Could that be what awaits you? Not an afterlife, not peace, just an infinite sequence of near-death experiences, each one pushing you further into the unknown. And then there's an even stranger thought. If your consciousness never stops experiencing reality, then what are you really? Are you just a passenger in an infinite, branching multiverse? A single thread in a sea of infinite possibilities. And if you can only experience survival, what does that say about the nature of reality itself? Maybe reality isn't objective at all. Maybe it isn't something we all share in the way we think. If consciousness can only exist in realities where it continues, then what if every person is trapped in their own endless, personal version of existence? What if death isn't the end of the story, but simply a transition into yet another reality where the story never stops? And then there's the biggest question of all. If quantum immortality is real, then what does that mean for God? If you never truly die, if your consciousness is simply shifting between realities forever, then does that mean you are the creator of your own existence? Does that mean there is no final judgment, no divine intervention, only an infinite series of chances, reshuffling the universe around you in a way that ensures you always experience something? Or could it be the opposite? Could this bizarre, terrifying mechanism of survival be the very thing that was designed? Could the laws of quantum mechanics be a reflection of something beyond our understanding? Something that ensures that no consciousness is ever truly lost? We don't know. Maybe we will never know. But one thing is certain. If quantum immortality is real, then the world you see right now, the life you are experiencing, may not be the only one you've ever lived. And it may not be the last. So, the next time you find yourself in an impossible situation, the next time you experience a moment of luck so improbable, it feels like fate, ask yourself, is it really luck? Or is it just the universe making sure you stay on the only path you will ever experience? What if you've already died 1,000 times? What if this, right now, is just the latest version of reality where you survived? We can't know for sure, but what if we could? If you love exploring the biggest mysteries of existence, don't forget to subscribe. And if this video made you question reality, check out this video on Who Created God if God created the universe.